very much, everybody, for joining the webinar today. The presentation is going to be delivered by myself and James. So I'm going to do the first segment. And so first of all, just to clarify with everybody some of the definitions and the terms that we'll use in this presentation, which may be familiar to some of you, but always worth clarifying because the climate change world has adopted its own definitions of terms that get used differently in other spheres. So first of all, we have the term adaptation, and adaptation is about taking action to prepare for the effects of a changing climate. Resilience, climate resilience, is the desired outcome, that the state we want to achieve by taking adaptation actions. Mitigation is around actions that are taken to avoid causing climate change in the first place. So that is actions to do with reducing greenhouse gas emissions. Now, this webinar is focused on the first two of these terms. It's focused on adaptation and resilience. So the first point I want to get across is around the fact that climate change is not some distant future prospect. It is actually something that has been with us now for decades, and it has taken us some time to see the signals of climate change. And so we have a graphic here on the right-hand side that shows how temperatures have increased since the onset of the Industrial Revolution to today. And these temperature increases are largely driven by man-made emissions of greenhouse gases, which have led to very significant concentrations of greenhouse gases in the atmosphere. And so what we're seeing is a rising trend in terms of temperatures. And if we look at some of these statistics here shown on the left-hand side, we're seeing year on year, very regularly, we're seeing records being broken in terms of global average temperature. There's always variability, natural variability, and many different natural cycles that are also influencing climate, but this upward trend in temperature is mostly driven by man-made emissions of greenhouse gases. And this topic of climate change, as everybody will know, I'm sure, is something that is treated with increasing concern in many quarters over time. And so we have had a statement from the World Economic Forum, various global business leaders who identify failure of climate change mitigation and adaptation as the greatest potential risk for the global economy. Okay. Now, I want to make a point here about mitigation and adaptation again. Even if we were to switch off all of the lights, all of the power stations, stop using cars all over the world today, in other words, to take incredibly drastic action to mitigate greenhouse gas emissions, we would not be able to stop climate change. Owing to lags in the climate system, we will still have to deal with climate change for decades to come. And the extent of future climate change that we will experience depends on the success that we have with mitigation efforts in the next couple of decades. And so this graph shows us two emissions pathways into the future, and the blue pathway at the bottom would represent a world where there were very aggressive actions to reduce emissions of greenhouse gases, and the red pathway would be more like current business as usual, where we carry on with growth in greenhouse gas emissions in line with current trends. And depending on which of those pathways the world adopts, we will have very different amounts of climate change to deal with over coming decades. So there is some climate change already built into the system that we need to adapt to, but mitigation actions can make a difference to how much we have to adapt to over the longer term. Now then, moving on to the hazards that stem from these changes in the climate system. We have here a list of the key climate-related hazards, which in turn have impacts on different elements of the oil and gas industry supply chain. So we have increasing temperatures over land and sea, and leading to, in turn, to increasing risk of heat waves. We have rising sea levels, changing rainfall patterns, and potentially changes in intensities of storms, tropical cyclones, hurricanes, etc. There's an important point to note on this graph, which is that there are different levels of confidence in these future changes. So you can see the arrow on the left-hand side going from high down to low confidence. So we have much greater confidence in our ability to project future changes in temperature than we do to understand whether or not there will be changes in storm intensities. These different degrees of confidence, in turn, would need to be reflected in different approaches to adapting to those risks, and we'll pick that point up a little bit later on. Now, this slide could in fact be a talk in its own right, but it's just a brief snapshot for you of work that ourselves and Worley Parsons Advisian have done with oil and gas companies over the last decade or so, where we have considered how those changing hazards can impact on different elements of the oil and gas industry. And so we have a whole range of fairly well-explored impacts for some oil and gas companies in terms of assets and operations. And those include things like how changing rainfall patterns and sea level rise affect flood risk and ground stability and drainage capacity. There are also impacts on assets to do with extreme events that can affect the integrity of assets. And then we have some impacts shown here like HVAC efficiency and equipment reliability that actually can be driven quite a lot by temperature increases. So there's a whole set of issues there which we've turned sort of within the fence line. If we then move along to the next segment, there are also a range of impacts to do with logistics and supply chains. And again, these can be within the fence line or outside the fence line, but typically this is to do with how climate change will affect water supply, power supply, the transportation networks, whether it's roads or ports or air transport on which the oil and gas industry relies. And then there's a set of impacts related to sort of social performance and communities. And within the fence line, this is often related to workforce health and safety, perhaps in environments where there are already high temperatures, which can restrict or affect operating practices. And then there are also a set of impacts beyond the fence line. So in terms of the interactions between an oil and gas company and the communities outside its fence line. And these communities obviously themselves will also be facing climate risks. And so thinking about how the communities will need to respond to climate change and how the oil and gas industry needs to respond helps to ensure that strategies that the industry might take will also, or certainly won't cause harm to local communities, and in some cases could benefit them. We then have a set of impacts related to environmental performance, and typically this can be to do with extreme rainfall events, overwhelming drainage systems, or it could be to do with discharge consents linked to rising temperatures of receiving water bodies. And then finally, there's a set of impacts related to energy demand. Now, rising temperatures and changes in rainfall patterns can affect heating and cooling and need for water, both within the fence line, but also, probably more importantly for the oil and gas industry, those changes in the market will be important for the oil and gas industry. So there's some very good research done by the International Energy Agency that explores how rising temperatures can affect demand for heating and cooling energy over coming decades. We also have a block at the bottom of this slide called wider stakeholders, which I will be covering in a minute. Just to give you a couple of examples then, this is some modelling that was done by Advisian to explore how climate change could affect flood risk and how adaptation actions taken at the level of a site could in turn have wider impact. So hopefully you can see on this diagram there's a red outline which is the site boundary, and this is a site in the Middle East that faces flooding from wadi flooding, and so an action that could be taken by the owners of this site could be to install a flood fund around the perimeter of the site to manage that flood water entering the site. However, if the company does that, this will divert the flood water away from the site, but that in turn will create new areas of flood risk outside the site boundary, and those are shown in the red colour on this slide. So there's a key point here which is around thinking about the impacts of the adaptation actions that might be taken to manage risk at a facility, considering what impacts those will have beyond the fence line and ensuring that there's a holistic approach to adaptation. These risks in turn translate into drivers for change, and here we have a bit of a focus now on drivers for change related to water. These topics here I'm going to cover on later slides, but essentially what we're seeing when we think about the interactions between climate change and water and development more generally, we can see that there's going to be pressures in terms of increased water scarcity and competition for water, increased costs for water supplies. In turn, both of those would lead to drivers to increase water efficiency, which will also bring their own costs. And then costs are associated with other types of asset protection, like the flood fund that we showed on the previous slide. And then we have actions that the industry will need to take to ensure security of the water supply. So I'll cover those in a little bit more detail on these following slides. So we see that globally there are increases in water tariffs that are being observed, and there's an average increase of around about 3.6% with a large variation that's been observed in recent years. Now, water tariffs in many developing countries are very low and are well below levels at which water infrastructure can be managed effectively. A lot of development partners are putting pressure on governments or recommending to governments that they increase water tariffs in order to promote more efficient use of water. And this action of increasing water tariffs is actually being sort of described as an adaptation action in many cases. So we can expect to see those increases occurring more often and cutting more deeply as pressures on water resources, in part driven by climate change, intensify. And we're also seeing increased costs of penalties being imposed on companies for over-abstraction, and also costs for related to discharges. And then this graph here on this slide covers another of the sort of financial issues around water costs, and this graph is showing the costs associated or the losses associated with flooding from rivers and flash flooding in OECD countries. And the difference between the dotted line and the long dashed line and the dotted line is the climate change impact on flood risk. So then, I mean, just to cover this briefly, because there's quite a lot of information on this slide, but essentially due to climate change, but also due to other pressures on water associated with population growth and socioeconomic development, we have a trend of increasing water scarcity and you can see the figures here in terms of the sort of projected changes in availability of groundwater, for instance, and then changes in the global population in areas of severe water scarcity by around about mid-century. So very much increased water scarcity being a key feature as time goes by. This in turn leads to increased competition for water, and agriculture is the main water user at the moment, and as climate changes, agriculture's needs for water will increase as well. So we have these sort of compounding threats related to pressure on these resources, which will be intensified by climate change. Now, really stepping above to the much broader sort of picture of wider stakeholders, there is a great variety of oil and gas industry stakeholders who are taking action to promote adaptation. And here I've got some examples from the financial services sector and also related to governments. And without going into all of the detail, some of you may have heard of the Task Force on Climate-Related Financial Disclosures, which has issued a report with some recommendations very recently. That task force is chaired by Michael Bloomberg, and that task force is encouraging voluntary disclosure by investors of the climate risks in their portfolios. This in turn means that investors will be looking to the companies that they are invested in their portfolios to understand the risks that these companies face, and in turn what actions companies are taking to address those risks. So this sort of feature of the financial sector needing to have a better handle on the risks in its own portfolios will in turn feed through to the companies that they're invested in. Some of you may have heard about Article 173, which was introduced in France recently, which is the first mandatory climate reporting standard for investors worldwide, and this is being looked at by governments in other countries to see if they should consider something similar. The pie chart here on the bottom right-hand side of the slide shows the number of countries that have put in place legal frameworks and policies related to adaptation and mitigation. And in the last 20 years, the number of climate change laws and policies has doubled every 5 years. And we now have 64 countries that have in place adaptation laws or policies. So these government policies can in turn have implications for businesses operating in those countries, and indeed offers opportunities for businesses in those countries to demonstrate leadership to their government stakeholders that they're taking on adaptation as well. So that's all I'm going to say in terms of the drivers for change. Now I want to briefly cover a couple of sort of what we term key principles for successful adaptation before I hand over to James. And so this first key principle is around what we term critical thresholds. So this diagram here shows a critical threshold shown by this solid horizontal red line. This critical threshold could be, so it's critical climate-related threshold. It could be something like the capacity of a surface water drainage system to cope with extreme rainfall events. So you might design a drainage system to cope with a 1 in 20-year rainfall event. So occasional exceedances of that critical threshold, in other words, times when the drainage system is overwhelmed, would be considered to be acceptable. But with a changing climate, which is shown by this, changing climate is shown by the blue line. You can see that we have an upward trend in this case in rainfall intensity, and that means that the design capacity of the drainage system would be exceeded more often. And at some point, the regularity with which it's being flooded becomes unacceptable, and action needs to be taken in order to increase the capacity of the drainage system, and that is shown by the blue block where we're adding in some extra drainage system capacity. This slide really emphasises the importance of identifying these critical climate-related thresholds and understanding what the climate change science is telling you about how likely those thresholds are going to be threatened into the future, in order to have an adequate planning time horizon to be able to take action to adapt before the problem really hits. Second key principle is around climate extremes versus incremental changes, and this comes out of the fact, I think, that in our experience there is a tendency, not just among oil and gas companies, but broadly there's a tendency to focus on the impact of extreme events. So a major hurricane in the Gulf of Mexico gets a lot of attention and garners a lot of interest. But in actual fact, our work with some oil and gas companies has shown actually that very often it is the incremental effects of rising temperatures that affect many assets in very subtle ways with small efficiency losses, but are occurring all over the world, you know, through all seasons with great regularity. And so while these are much smaller changes in their own right, because there are so many of them occurring, actually when you total up the costs associated with those, in many cases those can end up being more costly than these extreme events that garner all of the attention. So really what we're putting an emphasis on is on recommending that there is consideration of the whole range of changes, not just thinking about extreme events, but also these incremental changes as well. The final key principle that I'm going to mention is the concept of flexible adaptation planning, or adaptive management. And this is a very good strategy when you have uncertainty about future climate change. So to explain this diagram to you, the solid red line would show a level of risk increasing over time if there was no adaptation action taken. So this could be the risk associated with flooding of a coastal facility due to sea level rise. But we could have a lot of uncertainty about that red line because we have a range of possible rates of sea level rise in the future. So one response to that could be to adapt by building an expensive flood defence around the facility today to bring the level of flood risk down to an acceptable level over the lifetime of the asset. And that would be represented by the red dotted line. So you take one big expensive adaptation action now to provide protection against the risk over the longer term. The drawback of that approach is that if sea level rise isn't as great as you expected, then you've wasted money on an expensive measure. And so this is where the concept of adaptive management comes in instead, which is to say that instead what you do is you take smaller steps to manage your risk to acceptable level over time, and this is shown by the blue sort of sawtooth line. So rather than a one-off expensive adaptation measure, you would take a portfolio approach with a range of adaptation measures, and you keep on monitoring what's happening to sea level rise and adding in a new measure as and when it is needed to keep the risk below acceptable levels. This is exactly the strategy that is being used here in London as part of the Thames Estuary 2100 plan. So this flexible adaptation pathways concept is embedded in there. So this is the last slide from me, which is just to present a typology of adaptation and resilience measures. And James is going to pick up examples of these measures in his slides in a minute. Just to broadly explain this typology, on the left-hand side we have a range of actions that could be taken to build adaptive capacity. And so these include things like improving your information through research and monitoring and awareness raising. They include organisational changes like updating design standards to take account of climate change projections, and also actions related to governance of climate risk so that you're better positioned to be able to engage with stakeholders and explain to them how you're governing the risks. On the right-hand side of the diagram, we have physical adaptation actions. And you can see we have divided these up into 4 different categories. Grey adaptation measures are probably the most familiar ones. These are the hard engineering solutions like the flood defence scheme that I was mentioning before. There are also green adaptation measures, which are also called ecosystem-based adaptation, and James will give us an example of that in a minute. And then we can also have hybrid, which is sort of combination of grey and green. The final type of adaptation action on the right-hand side, though, is a really important one, which is often overlooked, which is operational changes. And what we have found in working with companies is that there is a lot actually that can be achieved in terms of smarter operations that can help to reduce climate risk without needing to pour concrete. So looking closely at the operational measures is a very good strategy to minimising costs associating with adaptation. I'm now going to hand over to James, who's going to pick up on terms of examples of some of those types of actions that I mentioned.
Okay, thanks, Richenda. So now I'm going to take through a few examples from projects, both in the hydrocarbon sector and also other sectors, to give them an insight into what sort of practical work's being done to be put in place in terms of adaptation. Not all of these examples are ones that we've worked on, that's Advisian and Acclimatise, but it's to give you an insight into what's being done across the broad spectrum. I'm not going to go into a lot of detail on the projects themselves, it's more just to get some key messages across. Okay, so this first example is looks at sort of the operational and hard engineering that's been done to adapt to climate change. So it's basically looking at those key principles that Jen was mentioning earlier. We're thinking about thresholds here. So climate change was identified early in the project at the concept stage. There was basically changing rainfall patterns, and then during the sort of feed stage of development of the project, those risks were incorporated into design through analysis of what those changing rainfall patterns might mean, then quantifying that over the change in the drainage basin. That basically results in a sort of a plus or minus type approach to adding on to your rainfall amount, and then your design is modified accordingly to account for those likely changes in the rainfall, and you design your facility to protect for that. And in addition to that, there's also sort of emergency planning done, where you're looking at making sure your evacuation routes from the site are also clear and are accessible even during those type of events. This example really is what we would term as almost as like a business as usual. This is your kind of the base case. This is pretty standard what people do. Look at what the risk is of climate change risk on their flooding of their site. Say, okay, we'll add on 10% to account for that, and that's their design basis going forward. So the next example is kind of going to the other extreme event, other extreme of the, and this is for an infrastructure one where actually they were looking at their entire supply chain and what the potential impact was on their entire chain in terms of access and egress to the port, but also because it's such a critical piece of infrastructure that had affected the logistics supply chain for the whole of Latin America and the Caribbean, is they wanted to understand the vulnerability not only to the port but also to other access and egress to the port, ships coming in and out, and their supply chain to make sure that they could effectively adapt to that going forward in the future. So what was identified, basically there was a number of small disruptions that could occur along many parts of that supply chain, which created, when all come together, creates quite a big disruption to the entire port operation. Some of the specific risks that were identified here related to sort of flooding affecting the access and egress to the port, sedimentation, which was affecting vessel movements in the port, but also impacts onto the infrastructure itself within the port and whether that would operate effectively. So a number of incremental changes here that could affect the entire supply chain of the port, which will then have an overall impact on the operation and the economic impact that that could have across the whole supply chain and affecting quite a large region. So the key message here is that they've looked at the whole value chain in this situation, not just their own facility. So the next example is thinking more about this sort of building adaptive capacity and looking at the investor interest that was taking place that Chen mentioned earlier. And this was a project looking more around sort of corporate and social responsibility and what they needed to understand the risks to their entire portfolio from climate change. And a part of that approach, it was a two-track approach looking at both the carbon and the sort of mitigation as well as the climate risk. They wanted to come up with a flexible adaptive plan to look at acceptable risks, and that included a sort of a quantification as well. So they wanted to look at a high-level estimation of what those, once the risks had been identified, what was the CapEx risk, what were the OpEx costs that were going to come forward from making those changes, so that they could decide how much risk they wanted to take forward, how much that they wanted to implement, and over what time periods that they could implement that. And as part of that program is also training of staff to understand some of those risks as well. Okay, so this next example is about is more about water governance. So this is in the Middle East, and it's a hydrocarbons project where it's already in a water scarce area. There's predicted increases in water scarce, so they were looking to build adaptive capacity and operational changes going forward, so that they could make sure that they're operating into the future and to minimise their risks and to ensure they've got sustainable water source going forward. There was also an additional issue here of the increasing water cut in their production of the oil coming out of the ground. So in this approach, they wanted to look at using the total economic value of the water supply that they were looking at to help them inform their decision making over time. So this was a study looking basically to value their water source, what value other people might have on it in the future, what other options it could be used for, and also to look at what the environmental benefits it was currently serving. And then they used the value that they got that was derived from that to then help them make their investment cases over the future to whether they wanted to look at alternative water sources, whether they should pipe it in from elsewhere, or looking at perhaps produced water reuse. And it just allowed them to build a more flexible plan, adaptive plan going forward. And apart from looking at one site, they also wanted to make this into a policy of looking at groundwater abstraction across all their facilities going forward. Okay, now in the next example, this is a slightly different case here where we're actually looking at resettlement of people that are going to be impacted by a new facility being built. This is in a very rural area of Southern Africa, and this is linking into the sort of IFC performance standards and performance standard 5 specifically, which relates to displaced persons and about them only being relocated once with the security of tenure. So generally speaking, the 4 communities around the world generally rely on sort of shallow groundwater to meet their needs in terms of drinking and domestic supply. So if you're going to relocate those people, water needs to be one of the first things that needs to be sorted out for them when they arrive in their new location. And linking back to that sort of performance standard, then you need to make sure that that water's going to be there almost in perpetuity, but obviously you can't go that far in advance. So in this project example, basically what was done was looking at what the climate change risks were in that area to see what impact that may have on water supplies and water quality, and also sort of flooding, and then to kind of zone out areas where perhaps it may not be advisable to move to resettle those people, and then allow a mapping to be done so that they can find the suitable areas to where they should be relocated. So this is sort of looking at a number of incremental changes that may happen over time and trying to evaluate that so that those people are so you're meeting IFC performance standard 5. So another water example, this one is looking more at availability and supply going forward, and this is the concept stage. And this was looking at the solution for this is the purple dot in the top corner is about hybrid solutions, is what came out of this one. So here, sort of climate change scenarios were looked at to look at the sensitivity of supply to the facility going forward, and then taking the output of that to then help identify what adaptation measures may be appropriate for the site, and to ensure that resilience is built into the facility to account for water supply over the entire production lifetime. So here a number of flexible solutions were looked at, which included things, sort of more green solutions, such as like ensuring existing sort of managed aquifer recharge schemes were run effectively and sustainably in the long term. Also things like upstream catchment management, looking at efficiency and irrigation practices to try and ensure that supply was not affected by those kind of impacts. And that's something that's seen sort of certainly within other industries like the utility companies, where they're very much focused now on sort of catchment management around their water sources and upstream catchment and irrigation practices to help protect their water sources. And then to offer the resiliency, there was additional sort of plan put in place to look at other supply options, such as building dams to increase availability of water and reduce pressures on other water supply, and make sure that there was continuous supply for the facility. So this next example is about building adaptive capacity, and this is a utility company where basically they're responding to legislative changes where they have to requirement to report on their current and future climate change risks and their adaptative proposals. So here they wanted to look at their maintenance and operation, and not just for their own company, but also in their supply chain. And they also wanted sensitivity testing to ensure that they could assess the risks appetite that they had for planning for adaptation. So this is tying back into one of those principles about critical thresholds. So here they actually developed a tool that would help them to identify the risks of all their assets and what those risks may look like, and they're trying to quantify the thresholds for those risks so they knew how to respond to them. So this is an example from utilities, and I know that some work has also been done by oil and gas companies looking at a similar type of approach as well. Okay, and then so this is something completely different, which is about sort of more an urban city type approach, and this is some work that's done across Asian cities to look at how they may need to build their adaptive capacity going forward. And what they looked at here is basically that they have to look at a multiple number of different issues in terms of how they may want to look at reducing flood risk and ensuring that there is available water supply going forward. Again, because the poorer communities rely on shallow groundwater. So this is the key take home from this is really that they're looking sort of beyond the fence line. They're looking at cross-sector initiatives, working amongst a number of different communities and stakeholders. But one of the key things here is also that by going out to all those communities and engaging with the stakeholders, they actually came up with some innovative and low-cost solutions to try and meet the adaptation that was required, and that just by simply making sure that they ensured the rivers were clean and that strategic waste management was put in place and it wasn't just dumped, which then ended up blocking riverways and causing flooding. Also trying to increase the infiltration capacity of the soil through simple methods of augers and using gardens to promote leaf litter and biodegradation within there, and degradation of the leaf and sort of vegetable matter within the gardens to try and increase soil infiltration capacity, thereby increasing the amount of water that could infiltrate going forward and trying to improve the amount of shallow groundwater available. So this is more about thinking about innovation and low-cost solutions, and that sometimes bringing in wider community can help with that kind of, it doesn't always have to be a hard engineering and expensive solution. The final example I'm going to present now is about the hydropower operation. So basically they were looking at, again, giving back at the principles mentioned earlier, it's about thresholds and how those thresholds may change in the future and how they need to build adaptive capacity to meet those changes. So here for the hydropower dam, they were concerned about hydrological changes in the future and whether they had sufficient capacity within their spillway to do that, what the revenue implications may be from some of those changes, whether there are safety requirement changes that need to be made, and also sort of normal and emergency operational procedures that needed to be considered. So that's the sort of last kind of practical example. So kind of bringing it all together now and talk about going back to that original diagram that we had earlier. So I think what we can kind of say is basically that you know, there's a lot of increasing pressures from external stakeholders here to demonstrate sort of good governance and organisational structures in place. At the moment, most of the work is done, kind of the information's been gathered, and there's been some hard engineering done, but there's perhaps been an underrepresentation on things like the operational changes, and perhaps some of the green solutions and the low-cost solutions that could also be implemented fairly simply and easily going forward. And generally that we're finding that, you know, operational changes don't cost a lot to implement and perhaps could be one of the easier wins and changes that need to be made, certainly from an investor perspective. But those changes also need to be thought about in a flexible way with sort of an ongoing management approach. I think that it's also worth noting that a lot of this can also be considered quite similar to sort of sustainability appraisals as well. So there's a lot of overlap there between other kind of stuff that's already being done. Okay, that's the last bit from us. So we can always provide more information on some of those projects if anyone wants.